So Oxford and Cambridge, they've always had beef.
Yeah. This research was coming from a Cambridge team studying the atmosphere of a planet called K218b.
He fit a bunch of different atmospheres, and he found that the atmosphere that had DMS and DMDS, which is dimethyl disulfide, so the best model that fit it was something that had a bunch of DMS and 1,000% more DMDS than we find on Earth. And both of these compounds are very much of biotic origin on Earth. That's mostly just made by like phytoplankton on Earth. Okay. So when we found that on this distant planet,
Phytoplankton must be there.
Yeah, it's like, oh, dope. Okay. So he publishes this thing, and immediately the BBC, they love tooting UK's horn. So they're like, oh, strongest evidence yet.
We did it.
Right? We did it. Here's the deal, though. You read the paper, and the significance level that these guys are saying is at 3 sigma, okay? 3 standard deviations. So we're 99.7% certainty. Might seem like a lot. In science, especially in physics and in astrophysics, that is not a lot. The gold standard is 5 sigma.
Okay.
Which is 99.9999%. Okay. 17th of April, this paper comes out. Understandably, there's a lot of backlash from the community. So a week later, this guy Jake Taylor from Oxford. A week later, so Oxford and Cambridge, they've always had beef. This guy comes out and he's like, actually with 6 different other models. With the same data.
This is the model of the potential atmospheres that could match. So the idea is Cambridge said, we found one that's a really close match.
Yeah.
Now Oxford came back,
and it's like, well, I did like 6 different methods of doing this, and only one of them showed DMS. But 5 of them don't.
So what are you talking about?
Right? 5 of these fits don't have any DMS, but they're fitting with this guy pretty nicely.
The accusation is kind of like you cherry picked one.
Yeah.
And you really didn't do
like an exhaustive search.
Right.
And that was a week after this guy published, right? He's a postdoc. He was just like, no.
About a week ago. A week is crazy.
A week, right? And then about 3 weeks later, the Americans start coming in.
We always do.
And because we want a little bit more time. So the Wellbanks group at the University of Arizona, they show pretty conclusively that like propine, which is C3H4 abiotic, can also produce the same signature. Okay, so it's like, well, you have you had like certain constraints on your atmospheric retrieval, but now like once we expand the search, there's all these other molecules that sort of fit the bill. University of Chicago does the same thing with all the data, and they're like, I don't see it.
So everybody's like,
bro, what are you doing?